Welcome back, students. Today in this session, we're going to start chapter number 7, triangles. In this chapter, you're going to learn about congruence of triangles, some of the criteria for congruence of triangles, and some properties of triangles. So, let us start. Let us start by knowing what is a triangle. A triangle is a polygon having 3 sides. So any polygon having 3 sides is called a triangle. Types of triangles are classified based into 2 groups based on their side and angle. Based on the side, triangles are classified into scalene triangle, types of triangle, scalene triangle, isosceles triangle, and equilateral triangle. So a triangle having all sides equal in length are called equilateral triangle, and the triangle in which 2 sides are equal are called isosceles triangle, and a triangle in which all the sides have different length are called scalene triangle. These are the types of triangles classified based on their sides, length of the side. And the types of triangles classified based on the angles are acute angle triangle, right angle triangle, and obtuse angle triangle. A triangle in which the angle is less than 90 degree, it is called acute angle triangle, and the triangle in which one of the angle is 90 degree, in which one of the angle is 90 degree, is known as the right angle triangle, and a triangle in which one of the angle is more than 90 degree is called an obtuse angle triangle. Now let us learn about congruence of triangles. First, let us try to understand the word congruence. Two figures are said to be congruent. Two figures are congruent if they are of the same shape, and of the same size. So two figures are congruent if they are of the same shape and of the same size. So any figure, if they have same shape and same size, then they are said to be congruent to each other. So what does it mean by congruence of triangles? Let us take two triangles, triangle ABC and triangle PQR. AB is of length 4 cm, AC is of length 3 cm, and BC is of length 5 cm. Likewise, PQ 4 cm, PR 3 cm, and QR 5 cm. So in these two triangles, you can see that in triangle ABC, the length AB is of same length as PQ in triangle PQR. Likewise, AC is of same length with PR, and BC is of same length with QR. So these two triangles are of the same shape and same size. So we can say that these two triangles are congruent to each other. We can write triangle ABC is congruent to triangle PQR. This is a symbolic representation of congruence of the triangles. So while writing the symbolic form, it is necessary to write the correspondence of vertices correctly. That is, you have to write the corresponding parts of the congruent triangles correctly. For example, in these two triangles, side AB is corresponding to side PQ. That is, vertices A is corresponding to vertices P. So if you start writing A as the first vertices for this triangle ABC, then you have to write PQR, P as first vertices for the triangle PQR. You have to write the corresponding vertices correctly. A, P, AP, B, Q, BQ, C, R, CR. If you happen to write as ABC, triangle ABC is congruent to triangle RPQ, then this will not be a correct representation of the symbolic form, as the corresponding vertices are misplaced. So it is very important to write the corresponding vertices in their correct places while writing the symbolic form for congruence of triangles. Suppose if in triangle PQR, PR is of length 4.5 centimeter, then we can say that these two triangles are not congruent, since length AC is of different length with length PR. So for two triangles to be congruent to each other, the triangles must be of the same shape and same size. Now let us learn some of the criteria for congruence of triangles. So under this topic, we are going to learn about Sas Congruence Rule, Asa Congruence Rule, Aas Congruence Rule, Ss Congruence Rule, Rhs Congruence Rules. We are going to study one by one in detail. So let us start by knowing what is Sas Congruence Rule. Let us first learn about Sas Congruence Rule. So according to this rule, two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. So to better understand this, let us take two triangles, triangle ABC and triangle PQR. Triangle ABC and triangle PQR, in which ABC is of length 2 centimeter, BC is of length 5 centimeter, and angle B is of measure 60 degree. Likewise, PQ is of length 2 centimeter and QR is of length 5 centimeter and angle Q of measure 60 degree. So in this two triangle ABC and PQR, you can see that side AB is equal to side PQ and measurement of angle ABC is equal to angle PQR, and side BC is equal to side QR, such that side AB equal to side PQ, and the included angle between these two sides, that is AB, BC, and PQ and QR. There is angle B and angle Q are of equal measure. So by Sas Congruence Rule, these two triangles, triangle ABC and triangle PQ, are congruent to each other. That is, triangle ABC is congruent to triangle PQR. So according to Sas rule, two triangles are congruent if the corresponding two sides of the given two triangle are equal, and also the included angle made by the two equal sides, formed by the two equal sides, are of equal measure. Then the two triangles are congruent to each other. Next, criteria for congruence of triangles is Asa Congruence Rule, which is given as Theorem 7.1 in your textbook. So by Sas Congruence Rule, two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangles. So in Asa Congruence Rule, there is angle side angle congruence rule. The two angles and the included side of the corresponding triangles are of equal measure and of equal length. Let us try to prove this theorem, that is Asa Congruence Rule. Now let us try to prove the Asa Congruence Rule. So according to this rule, if two triangles are to be congruent, that is triangle ABC is congruent to triangle DEF, then angle B is equal to angle E, angle C is equal to angle F, and the included side, that is side BC, is equal to side EF. Then these two triangles ABC and triangle DEF are congruent to each other. To prove this theorem, let us take up three cases. That is case number one. In case number one, we are going to assume AB is equal to DE, that is side AB is equal to side DE. And in case two, we are going to assume that side AB is greater than side DE. And in case 3, we are to assume side AB is less than side DE. So, given in triangle ABC and triangle DEF, angle ABC is equal to angle DEF, side BC is equal to side EF, and angle BCA is equal to angle EFD. So in case number 1, we are assuming that the side AB is equal to side DE. Then if you closely observe these two triangles, AB is equal to DE and angle B is equal to angle E. This is the already given in the statement. And side BC is equal to side EF. That is, AB is equal to DE. This is the case number 1. That is, we assume AB is equal to DE, and angle B is equal to angle E, already given, and angle side BC is equal to side EF. This is also given in the statement. Then by applying, then by Sas Congruence Rule, that is side angle side, side angle side, the two triangles ABC and DEF are congruent to each other. Then by Sas Congruence Rule, triangle ABC is congruent to triangle DEF. This is the first case where we assume side AB is equal to DE, which proves that according to Sas Congruence Rule, these two triangles are congruent to each other. Now, let us take the second case. In the second case, we assume that AB is greater than DE. That is, side AB is greater than DE. In this case, if we take a point P on AB such that PV is equal to DE. So now let us try to prove that the triangle ABC is congruent to triangle DEF. For case 2, we take point P on AB such that PB is equal to DE. Then PB is equal to DE, angle B is equal to angle E, and BC equal to EF. These two are already given in the statement. So this also by Sas Congruence Rule, triangle PBC is congruent to triangle DEF. Since these two triangles are congruent to each other, angle PCB is equal to angle DFE. But we are given that angle ACB is equal to angle DFE. Now angle ACB, from these two, angle ACB is equal to angle BCB. Angle ACB is equal to BCB. This is only possible when B coincides with A, or in other words, AB is equal to DE. Therefore, triangle ABC is congruent to triangle DEF by Sas Congruence Rule. That is, AB equal to DE, and angle B equal to angle E, and BC equal to angle EF. So by Sas Congruence Rule, triangle ABC is congruent to triangle DEF. So in second case also, we prove that triangle ABC is congruent to triangle DEF. Now let us take up the third case in which AB is less than DE. For this, we will take a point M on DE such that EM EM is equal to AB. So we take a point M on DE such that ME is equal to AB. We can proceed same as this argument to prove this third case. Then AB equal to ME, angle B equal to angle E, and BC equal to EF. So by Sas Congruence Rule, triangle ABC is congruent to triangle MEF. Since these two triangles are congruent, angle ABC is equal to angle MEF, but angle ABC is equal to angle DEF. So angle DEF is equal to angle MEF. This is only possible when D and M coincide with each other. So ME is equal to DE. That is, AB is equal to DE. So by Sas Congruence rules, triangle ABC is congruent to triangle DEF. By Sas Congruence rule, that is, side AB is equal to side DE, side BC is equal to side EF, and the included angle B is equal to angle E. Next congruence rule is Asa Congruence Rule. So according to this rule, two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equals. For example, in these two triangles ABC and PQR, ABC and PQR, if any two pairs of angles, there is angle A is equal to angle B and angle B is equal to angle Q, and one pair of corresponding sides, let's say AC is equal to PR, then these two triangles, triangle ABC is congruent to triangle PQR. This rule is known as Asa Congruence Rule or angle-angle side congruence rule. In this rule, the corresponding equal sides, there is side AC and side PR, is not included between the corresponding equal pairs of angles. There is angle A, angle B, and for triangle PQR, angle B and angle Q. Next criteria for congruence of triangles is Sas Congruence Rule, which is given as Theorem 7.4 in your textbooks. The statement says if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. So if all the three sides of one triangle is equal to the three sides of another triangle, then the two triangles are congruent. Suppose in triangle ABC and triangle PQR, side BC is equal to side PQ, side AB is equal to side PQ, and side BC is equal to side QR, and side AC is equal to side PR. That is, all the three sides of this triangle ABC is equal to all the three sides of the triangle PQR. Then triangle ABC is congruent to triangle PQR. Next criteria for congruence of triangle is Rhs Congruence Rule. That is right angle hypotenuse side congruence rule, which is stated as Theorem 7.4 in your textbook. The statement of the theorem says if in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. So according to this congruence rule, if in two right triangles, for example, there is in right triangles A, B, C and right triangle D, E, F, right angle at B and right angle at E for triangle DEF, the hypotenuse AC is equal to the hypotenuse DF, and one side of the triangle, that is side BC, is equal to side EF, then these two triangles are congruent to each other. That is, triangle ABC is congruent to triangle DEF. So in these two triangles, triangle ABC and triangle DEF, hypotenuse AC is equal to hypotenuse DE, and side BC is equal to side EF, and angle B is equal to angle E, which is 90 degrees. So these two triangles, triangle ABC is congruent to triangle DEF. Now let us learn Theorem 7.2, which come under the heading Some Properties of a Triangle in your textbook. The theorem states that angles opposite to equal sides of an isosceles triangle are equal. So in an isosceles triangle, the angles opposite to the equal sides, suppose triangle ABC is an isosceles triangle in which AB is equal to AC. Remember that an isosceles triangle is a triangle in which two sides are of equal in length. So in this triangle, in this isosceles triangle ABC, side AB is equal to AC. So according to this theorem, angles opposite to the equal sides, that is angle C opposite to the side AB and angle B opposite to the side AC are of equal measure. Let us try to prove this theorem. So given a triangle ABC in which AB is equal to AC. That is, ABC is an isosceles triangle. To prove, what we are going to prove is angle B is equal to angle C. Proof. To prove this theorem, we draw the angle bisector of angle A such that D is the point where this angle bisector meets the side BC. Since AD is the angle bisector of angle A, this angle will be equal to this angle. So in triangle ABD and triangle ACD AB is equal to AC. Why? Because these are the equal sides of the isosceles triangle ABC. And angle and measure of angle BAD is equal to measure of angle CAD, because AD is the angle bisector of angle A. And also AD is equal to AD. That is, this is the common side to both triangles ABD and ACD. This is the common side to both the triangles. Now, by Sas Congruence Rule, triangle ABD is congruent to triangle ACD by Sas Congruence Rule. Since these two triangles ABD and triangle ACD are congruent to each other, measure of angle B is equal to measure of angle C. Hence, proof. Next property comes under the heading Theorem 7.3, which states that the sides opposite to the equal angles of a triangle are equal. This is the converse of Theorem 7.2, which we have just learned, which states that angles opposite to equal sides of an isosceles triangle are equal. So according to this Theorem 7.3, the sides opposite to equal angles of a triangle are equal. For example, if this is an triangle, given triangle ABC, these two angles are equal, that is angle B and angle C are equal, then the sides opposite to this angle, that is opposite to the angle B, is side angle C, and opposite to the angle C is side AB. So these two sides AB and AC will be equal. That is, if in any given triangle, for example in this triangle ABC, if angle B is equal to angle C, then the side AB will be equal to AC. Next, we will study Theorem 7.6, which come under the heading Inequalities in a Triangle. This theorem states that if two sides of a triangle are unequal, the angle opposite to the longer side is larger. For example, in triangle ABC is an scalene triangle in which AC is the longest side. AC is the longest side. So the angle opposite to this side will be the greatest angle of all these three angles of a triangle. So AC is the longest side. Then angle ABC will be the larger angle among the three angles of the triangle. Next is Theorem 7.7, which states that in any triangle, the side opposite to the larger angle is longer. It is the converse of Theorem 7.6. So suppose in a triangle ABC, if angle B is the larger angle among the three angles, then the side opposite to this angle, that is angle B, side AC, is the longest side. Next is Theorem 7.8. The sum of any two sides of a triangle is greater than the third side. For example, in triangle ABC, side AB plus BC is always greater than side AC. Or side AB plus AC is greater than the third side, that is BC. Or side BC plus AC is greater than the third side, AB. So in any triangle, the sum of any two sides of a triangle is greater than the third side.